Brief review of Cartesian system of rectangular coordinates. We are discussing about the Cartesian system of rectangular coordinates and Cartesian systems. So Cartesian coordinate system, what it is? We write it as Cartesian, right? Now this is a rectangular coordinate axis system. How do we make it? First, we on a plain piece of paper or on a plane, we divide it into two parts with two lines which are perpendicular to each other. That means all the angles between these lines are 90 degree. Then the horizontal line, we term it as x-axis. We call it as x-axis, and the intersection point is called the origin, the intersection point. So we give the arrow sign. X dash is the horizontal line, and vertical line perpendicular to the horizontal line is y dash. When we go on the right hand side, it's going to be plus. When we go on the left side, it's going to be negative, positive, negative. When we go up, it's positive, that is y will be positive. When we go downwards, y will be negative. So how do we do this? What is positive, what is negative? We divide the line into proper scale. It depends on what kind of measurement you are looking for. So it is totally at your disposal how much measurement you give. But whatever measurement you are taking, say for 1 unit length, then every distance should be similar. So right hand side 1, 2, 3, left hand side -1, -2, -3. So the distance between 2 and 3 will be equal to the distance between -2 and -3. They have to be exactly same. Now going up, same thing, that is +1, +2, +3 for positive y-axis we call. Then we have -1, -2, -3. This is negative y-axis. This is called Cartesian coordinate system. Now we have a point. How the whole thing is to locate a point, to locate a location. So we have a point. So now draw a line which is parallel to one axis and perpendicular to another axis. That is, we are making a line parallel to y-axis, perpendicular to x. We are drawing a line parallel to x-axis, perpendicular to y. So this xy is nothing but the distance. X is the distance from y-axis, this point. X is the distance from y-axis, this is x, and y is the distance from x-axis. Y is the distance from x-axis. That is, if this is a starting location, you go on the right horizontally and go up vertically. This is x and this is y. And what is the distance? Of course, under root x square plus y square, because everything is perpendicular here. Now since you see, when we make a point P, in order to find location, we have inadvertently made a rectangular. So in order to locate a point, say I have a point here, so we have to draw a line parallel to both the axes. They are going to intersect, and wherever they are intersecting, these lines, imaginary lines, these are the xy coordinate. That is why a rectangular we are making. That is why we call it as a rectangular coordinate, Cartesian coordinate system. That is why I call it as. So we have a piece of paper, we divide it into 4 parts, and these 4 parts are called quadrants. This quad means 4. Quad means 4. So we have quadrants, 4 parts. In the first quadrant, x is greater than 0, y is greater than 0. So this is the first quadrant, second quadrant, third quadrant, fourth quadrant. So we go anti-clockwise like this. So in the second quadrant, x is less than 0, y is greater than 0. Here x is less, the third is x less than 0, y less than 0. Fourth, x greater than 0, y less than 0. Origin is 0, 0. If you want to locate, I am just giving an example. If you want to locate -3 and -2, x is less than 0, y is less than 0. So where it should lie? It should be in the third quadrant. So this point will lie in the third part of that plane, rectangular Cartesian coordinate system. Coming to the distance between 2 points, how do we, let us make this Cartesian coordinate system again. Now here, there are 2 points. It can be anywhere. So this is one point P, this is another point Q. P can be represented by x1, y1. Q can be represented by x2, y2. Now we want to find out the distance between them. So let us make 2 lines, means x1 and x2 and y and y2. That is lines parallel to x-axis, line parallel to y-axis. So how do we find out the distance? So if this is r, so it is actually PQ will be RP square plus RQ square. This is again a triangle and we can use the Pythagoras theorem. So what is the total distance? x2. What is the distance here? The second distance x1. So the actual RQ will be x2 minus x1. x2 minus x1. And then let us say the x1 is there. So the highest distance y1 is the highest distance and y2 is the lower distance. So what is the distance? y1 minus y2 or y2 minus y1. So what is the x2 minus x1 you can take, and y1 minus y2 or y2 minus y1 you can take, and since it is square, we are using the Pythagoras theorem. Since it is square, it doesn't matter, you put x2 or x1 earlier, or you can just exchange them. Now this distance will be distance of abscissa and distance of ordinates. Distance of abscissa and distance of coordinates. Now there are certain useful points to be noted. Now if you have a square, you have to prove that it is a square. So you need to prove that 4 sides are equal and the diagonals are also equal. Now if you want to prove, or in the question it is being said, prove it is a rhombus. So you need to prove that 4 sides are equal. Now if you need to prove a rectangle, we have to prove that opposite sides are equal. Opposite side, this is a figure, so these are the opposite sides. So opposite sides are equal and the diagonals are also equal. In order to prove a parallelogram, so parallelogram it is whose opposite sides are parallel. So parallelogram has opposite sides parallel. Now we have to show that the opposite sides are equal. Now you have to prove that it is a parallelogram but not a rectangle. Parallelogram but not a rectangle. Then we have to prove that the opposite sides are equal but the diagonals are not equal. The diagonals are not equal. In order to prove the rhombus but not a square, a figure is a rhombus but not a square, then we have to prove that its all sides are equal but the diagonals are not equal. All sides are equal but the diagonals are unequal. This is how we do it. There is one more thing. There are 3 points and we are saying that they are collinear. Collinear means they are in same line. They fall on a same line. One line they come. That is, they are 3 locations on the same road. So when you add the distance between 2, there are 3 pairs. So you take the distance and 2 distance, if you add, it should be equal to the 3rd distance. Then we have the area of triangle. Area of triangle. Now we have a direct formula here. If we know the coordinates of 3 points. So if we have x1, y1, x2, y2 and z2 as 3 location or position on a Cartesian plane, A, B, C, we can identify it. So now there is a tariqa, there is a way how, clockwise and anti-clockwise you are going to take. I'll just show you. First is this half and you use the determinant. If you know determinant, it's good. Otherwise, I'll tell you the other way. So x1, x2, x3, y1, y2, y3, 1, 1, 1. If you are not aware of discriminant, let me write the formula directly. So half, you start with x1. Then you take y2 and y3 here. Then you have x2. Then you take y3 minus y1. When you take x3, you take y1 minus y2. So this is the formula. This is the area of triangle. Now if you take anti-clockwise, that is, if you take B, C and then A, the area will be positive. And if you take B, A and then C, that is the clockwise direction, the area is going to be negative. Now again, coming to the collinearity, if 3 points are there and if they are in a same line, the other way to prove it is, because if the 3 lines are there, they cannot make a triangle. So if these 3 points are in the same line, the area of the triangle should be equal to 0. The area of the triangle should be equal to 0. This is a collinearity condition. 3 points, take the area, put it to 0. This will show that the 3 points are collinear or not. Next is the section formula. Section formula. Section formula means if you have, say, a line or you join 2 points, you take one as A, x1, y1 is the position, and second B which is having x2, y2. Now if you have a point, say P in between, and say that the coordinate is xy. Now you want this P is dividing AB in ratio m:n. So the coordinate of x can be easily found out by mx2 plus nx1 by m plus n, and y is my2 plus ny1 by m plus n. So x and y can be found out easily. There is a directly formula. This is the internal division. This is the internal division. Now when we have a point which is outside, that is, the point is externally dividing the 2 points. So just take the negative everywhere. That is mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n. This is how we can use the section formula to get a point which divides the line into m:n. One more thing is the locus and the equation to a locus. Locus and equation to a locus. So locus, the best example is circle. Let us say you have a wood, you have pressed it inside a ground, and you have a donkey or say a horse which is tied to this wood. Now the grazing area can only be a circle because there is a locus. You have defined that this is the string length by which he is, or the horse is tied, and it can just move around to an area. So you have a say point which moves like this with under certain situation mathematics. So one can be a circle or it can be an ellipse. So how do we do that? First of all, locus is the curve described by a point which moves under a given condition or conditions is called its locus. So how to do this? First is algorithm I am telling you. First, assume the coordinates of a point, let us say hk, whose locus is to be found. First, we have to find out the locus. The equation to the locus of a point is the relation which is satisfied by the coordinate of every point on the locus of the point. So we will start with h comma k. We'll take an example. Then we have to write the given condition in mathematical form involving h and k. Then we have to eliminate the variables if any. Then finally we'll replace h by x and k by y in the result which is obtained in the step 3. So the equation so obtained is the locus of the point which moves under some stated conditions. I'm going to take an example. Let us take an example. Find the locus of a point so that the join of minus 5, 1 and 3, 2 subtends an right angle at the moving point. So there are 2 points. Whenever we join them, or a point which is moving such that whenever you join these any point on this line which is the locus line or locus curve, it will always be perpendicular. That is, one point is minus 5, 1, the other point is 3, 2. So whichever point is making a locus, whenever you join it with these 2 points, it's going to be 90 degree. It will be 90 degree. So let us take a proper structure here. That is, this is 90 degree, this angle is 90 degree. One point is minus 5, 1 and 3, comma 2. So we have to find out the locus of that point, which always make this 90 degree. So this, let us assume that this point is h comma k. Then since the distance, because the angle is 90 degree, so we can use the Pythagoras theorem. So let us join this. We are making a right angle triangle. So these two, say, let us say this point is, take A and B. So PA square plus PB square will be equal to AB square. So distance we are going to find out. So distance between 2 points is 3 minus 5, this is 3 plus 5 whole square, 2 minus 1 whole square equals the distance between these two, h minus 5, h plus 5 whole square plus k minus of k minus 1 whole square, and plus now this distance PB, h minus 3 whole square plus distance formula we are using, k minus 2 whole square. So whenever we solve it, you are going to get h square plus k square plus 2h minus 3k minus 13 equals 0. Now now we are using final step. Final step is just replace h and k by x and y. So x square plus y square plus 2x minus 3y minus 13 equals 0. So this is how we find out the locus. Shifting of origin. Shifting of origin. This means that we have a coordinate system. A Cartesian coordinate system you have made or you are given. You are shifting this Cartesian coordinate system now. This origin O, which is the intersection of these 2 points 0, 0. Now you try to shift it to O dash. So what is the relationship between O and O dash? So we are moving this coordinate axis to another position. So let us say that this is the dotted line I am making. This dotted is a new coordinate system. We have shifted it. So what are you going to get? How do you shift it? What are the new coordinates? So let us say we have x comma y. X comma y is with respect to the original coordinate system. This is x, that is the distance from y-axis, y is the distance from x-axis. So x is this distance and y is this total distance. Now this xy is the distance from the coordinate axis. Now we have new axis where the coordinate becomes h comma k. Previously it was 0, 0. Now what is the xy with respect to hk? Xy was with respect to 0, 0. Now what is the xy with respect to hk? So hk is what? This distance, and k is this distance. Similarly, the way we presented xy, it will be h and k, right? Now new coordinate system is what? New coordinate system. The old coordinate system, it was, this point was x comma y. With the new coordinate system, say this xy becomes capital X capital Y. This same xy with respect to new coordinate system, let us say it has changed to capital X capital Y. Now see the diagram. This is capital X, right? And this new coordinate, just forget about the previous coordinate system. Now let us take the new coordinate system. So this is the new coordinate system, and we are saying that on the new coordinate system, this is now capital X capital Y. So capital X is this distance and capital Y is this distance. So this distance is capital Y, this distance is capital X. Now see, there is a relationship. This x is actually small x is equal to h plus capital X, right? It's very obvious from the diagram. And what is y? Small y. It's equals k plus capital Y. K plus capital Y. So what is the new coordinate system? Capital X will be equal to x minus h and capital Y will be equal to y minus k. So the new coordinate system is x minus h, the original coordinate system, minus h, and the new coordinate system minus k. That is, the 0, 0 has changed to minus h minus k eventually. 0, 0 has changed to minus h minus k. Let us take an example. At what point the origin is shifted? if the coordinates of a point 4, 5 becomes minus 3, 9. So at what point the origin is shifted? Origin is 0, 0. Where it should be shifted? So that the 4, 5 was small x, small y, and the capital X and capital Y will become minus 3 and 9. That is, the 4 and 5 was small x and small y with respect to initial origin. Now it has to become minus 3 and 9, that is capital X and capital Y. So what is the h and k? What is the h and k we have to find? So 4, 5. At what point the origin be shifted if the coordinates of a point 4, 5 becomes minus 3, 9. So small x, small y, that is the original is, with respect to original is 4 or 5. With respect to new origin, it has to be minus 3 and 9. Minus 3 and 9. So we already have a formula we just saw. X equals x plus h, capital X plus h, and small y equals y plus k. Now put it here. We have to find out h and k. So 4 equals minus 3 plus h, 5 equals 9 plus k. Small, this h will be 7 and k will be minus 4. So the origin must be shifted to 7 comma minus 4. 7 comma minus 4. This is how the new coordinate system is minus 3, 9. So this is about the shifting of origin. So this is all about the brief review of Cartesian system of rectangular coordinates. We are going to see the question. Okay, thank you so much. Take care of yourself.